Good afternoon, math class. This is our quiz that we did last week. You should already have gotten a copy of it yesterday. If not, ask the sub for a copy of it and try going over this yourself too. I'll go over every question in this video. Feel free to fast forward to the questions that you didn't understand or maybe just need help with. I'm also going to go kind of quickly through them. So please pause, rewind whenever you need to so that you can get a good understanding of each question. All right, let's get at it. Number one, which expression correctly describes the theoretical probability where x is the number of times event x occurred and s is the number of outcomes possible? Okay, there's a lot of words there, right? So, which expression correctly describes probability where x is the number of times outcome occurred and s is the number of outcomes possible? We know that probability equals what you want divided by what's possible. In this case, they're saying x is the number of times event x occurred. So that means x is what you want. Divided by what's possible, it says s is the number of outcomes possible. S is possible. That means the probability of x is x over s. The answer should have been D. Okay, number two, given the following probabilities, which event is most likely to occur? Okay, remember that probabilities range anywhere from 0 to 1, right? And decimals in between. The closer to 1 you are, the more likely it'll happen. So the bigger the decimal you are, the more likely it'll happen. So if we put all of these things in our calculator and change them all to decimals, 1 divided by 4 is 0.25, and 1 divided by 5 is 0.2. The largest decimal is the most likely thing to happen. In this case, 0.28 is the largest decimal, therefore A is the most likely thing to occur. Question 3. The odds in favor of Mr. Kennedy passing his bus license test on the first try are 7 to 4. Determine the odds against Mr. Kennedy passing his license on the first try. Okay. It's asking for determine odds against. That means you want to do what you don't want as the first number and what you do want as the second number. The information they gave you said the odds in favor. Odds in favor is what you want first, what you don't want second. The odds in favor of Mr. Kennedy passing his bus license on the first test are 7 to 4. That's what you want, 7 things. That's what you don't want, 4 things. We want to switch that to odds against. So we just have to switch the numbers. Odds for and odds against are just opposites. It's stating the same thing but in reverse. So the answer to this would be 4 to 7. Miss Tuckluck draws a card at random from a deck of 52 playing cards. Determine the odds in favor of a card being a heart, given that there's 13 hearts in the deck. Okay. We want to determine odds in favor. Okay, that means you want to put what you want first, what you don't want second. In this question, it says, I want a heart, and there's 13 hearts. So there's 13 things that I want. What I don't want is not a heart. Now, not a heart is not given to you. What is given to you is that there's 52 total cards. 52 total cards. If you subtracted away all 13 hearts, that would tell you that there's 39 cards that are not hearts. So that's the total number of cards, 52, minus the 13 hearts, giving you 39 cards that are not hearts. That's what I don't want. So the answer is 13 to 39. Now, looking at the answer on the left, that's nowhere to be found, right? I can't find that answer. There's no 13 to 39. And that's because you can reduce these things. So you can reduce odds if there's a number that divides into both of these. Both of these numbers actually divide by 13. When you divide both by 13, you get 1 and 3. B is the answer. That means for every one heart in the deck, there's 3 non-hearts in the deck. For every one card you do want, there's 3 cards that you don't want. Awesome. Number 5. Mr. Stedman likes to go rock climbing. In the past, Stedman has climbed to the top of the wall 7 times in 28 attempts. Determine the odds against climbing to the top. Odds against. That's what you don't want first versus what you do want second. Okay, it said Stedman climbed to the top of the wall 7 times in 28 attempts. Determine the odds against climbing to the top. Okay, so that would be 7 things that I wanted, right? Because I want to get to the top. So that 7 goes here. I want to get to the top. There's 7 times I actually got there. What I don't want is to fail. They didn't tell me how many times I didn't make it, but they told me that I tried 28 times. So we're going to do our trick again. We're going to go 28, and we're going to subtract the 7 things we did want for a total of 21 times that we failed. We never made it to the top. That's my don't want. The answer is 21 to 7. Again, you'll notice that that answer is not there. That's because I can divide both these numbers by 7. The answer is 3 and 1. A was the solution. Number 6. Mr. Chowwood has 12 coins in his pocket, and 9 of those coins are quarters. He reaches into his pocket and pulls out a coin at random. Determine the probability. Okay, probability is what you want divided by what is possible. Determine the probability that the coin is a quarter. Okay, I like to write this out. What I want and what's possible. What I want is a quarter. I want a quarter. It said that there's 9 quarters. So there's 9 things that I want. What's possible is I could pick any of the 12 coins in his pocket. So it's 9 divided by 12. If you put that into your calculator, you should get 0.75, which is C. They have 0.750, but that's the same thing, right? You just add a 0 to any number, any decimal, it's the same. Awesome. Number 7. Miss Schaub notices in a flyer that corn is on sale at the grocery store. The last 8 times that corn was on sale, it was available only 3 times. Determine probability that corn will be unavailable this time she goes to the store. Probability is what I want divided by what's possible. I want corn to be at the store. Well, according to our trials from before, the last 8 times that corn was on sale, only 3 times it was there. So only 3 times did I get what I wanted out of 8 possible attempts. The probability is 3 divided by 8. You put that in your calculator, it's 0.375. Number 8. Karen Smith has ESPN and can tell when it is raining. She says that there's a 0.8 probability that it is already raining outside. Determine the odds it is raining outside. Okay, there's different ways to do this. But you're going to have to convert from probability to odds or odds to probability, one way or the other. So remember that probability is what you want divided by what's possible. Odds it is raining, so that'd be odds 4, is what you want versus what you don't want. Cool. That means these two things are the same. The number on top of my probability and the first number in my odds are both what I want to have happen. The difference is the second numbers. When you're doing probability, you're dividing by what's possible, which would be the want plus the don't want. When you have the don't want in odds, that's what's possible, subtracting what you do want. So, to convert from odds to probability, I need to add these numbers together to create the possible. So this is really 4 over 9. This is really, if you add those, 4 over 5. Add these, it's 4 over 6. If you add these, sorry, that's a 1 over 6, not 4 over 6. It'd be 1 over 5. You could then change all of those into decimals to figure out which one equals 0.8. If you did that, you would find that this one is 0.8. So the answer is B. The other option would be to go the other direction. If you put in your calculator 0.8, you hit the math and then the frac button. It'll change this into a fraction for you. And that fraction is 4 over 5. That means there's 4 things that I want, 5 things that are possible. If I wanted to change that into odds, that means there's 4 things I want, and there's only 1 thing that I don't want. Because if there's 5 possible, the difference between 5 and 4 is 1. It was 4 to 1. Number 9. Karen Smith can also use her ESPN to tell when it is going to rain tomorrow. She claims a 50% probability of rain tomorrow. Determine the odds against rain tomorrow. 50% probability means there's an equal chance of it happening and not happening. This also says there's an equal chance of it happening and not happening. For every time that it happens, there's 1 time that it doesn't happen. 1 to 1. It's called even odds. Number 10. Vegas says there's a 0.4 probability the Flames win their next hockey game. What is the probability they lose their next game? Lose would be the opposite of win. Right? Those are called complements. Opposites. We know that complements should add together to be 1. So if you want to find the complement of something, you go 1 minus whatever the probability of the other thing is, 0.4. And that will tell you the probability of what you don't want, which is losing. 0.6 is the answer. Again, if you look, none of these match up. So you should be putting these in your calculator into decimals, right? 2 divided by 50, 3 divided by 50, like that. You should find that this one is 0.6. The answer is D. Number 11. 4 boys and 3 girls will be riding in a van. Only 2 people can sit in the front of the van. What is the probability of the first person to get in the van is a boy, and then the second person in the van is also a boy? Okay. Probability. So I'm doing want versus possible. But there's another key here. There's 2 things that happen. The first person is a boy. The second person is a boy. And this keyword. And. What it's asking is, what is the probability of the first thing and then the second thing happening? We write this in our formula sheet like this. Probability of A and B. And if you look at your formula sheet, it'll tell you that the probability of A is equal to, and B is equal to the probability of A times the probability of B given A happened. More likely, what I would just say is the word and tells me to multiply these 2 situations together. Multiply the first probability and multiply the second probability. And that should give you your answer. Okay, so what's the probability the first person is a boy? Well, there's 4 boys. So there's 4 things I want. Divided by, there's 3 girls. So that means the possible number of people who get in the van would be 7. Right? 4 plus 3 equals 7 total people. So the probability that the first person is a boy would be 4 over 7. We need to multiply this by the probability that the second person is also a boy. All right. The second person being a boy is not 4 divided by 7 because one of the boys is already in the van, right? They got in the first seat. That means there's now only 3 boys left to choose from for that second seat. Divided by there's only 6 people left to choose from for that second seat. The answer would have been 4 divided by 7 times 3 divided by 6. If you put that in your calculator, you should get 0.2857, which rounds to be 0.286. The big key here, and means multiply. As soon as I see that conversation happening, I know I need to multiply my probabilities together. Awesome. Number 12. Mr. Dunnigan tosses 4 coins in the air. Determine the probability that they all land on tails. All right. These are called compound events. Compound events are when the same thing happens multiple times, over and over and over again. The way that we tackle compound events is with trees or with charts. All right, so we're going to do a tree. We're going to do our first flip. We're going to flip our coin. You're either getting heads or you're getting tails. Then you're going to flip again. You're either going to get heads or you're going to get tails. Same thing here. You're going to get heads or you're going to get tails. Then you're going to flip again. You're either going to get heads or you're going to get tails. Right, this is our trees. We use these for repeated events. And we have to flip one more time. To get all of our possible outcomes here. Like that. What we wanted was the probability that they all land on tails. This is the only way I get tails. Tails, 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 tails. There's only one outcome that I want to have happen. The number of possible outcomes here, though, is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 possible outcomes. So there's one thing that I want divided by 16 things that are possible. You put that into your calculator, and I believe you get 0.0625, but I'm going to double check. Yeah, you do, 0.0625. The answer is A. Question 13. Mr. Hart and Ms. Wilson are playing a board game with 2 dice. If a player rolls a sum greater than 9, the player gets a bonus of 50 points. Determine the probability of rolling a sum greater than 9. Okay, sum is adding together, right? This is another compound event. So our compound events, we have 2 choices. We make trees or charts. This time we're going to make a chart. So this would be dice 1. You could roll 1, a 2, a 3, a 4, a 5, or a 6. Right? That's with your first dice. You could roll any of those things. With your second dice, you could roll a 1, a 2, a 3, a 4, a 5, or a 6. Now, when you roll these dice, what you're doing is you're adding them together, right? Because it said sum. So you're looking at what happens when I roll these dice. What are the possible things they could add up to become? We make our little chart. Inside every one of these boxes, I'm going to put what the two dice add together to be. So for instance, 1 plus 1, it would be 2. All right, so you're going to add all of these boxes together to find all the possible outcomes that you could get. You'll notice they just kind of follow a pattern of them adding. Perfect. And there are all the possible outcomes that you could get from rolling these dice and adding them together. Now, what you wanted was to find the probability of a sum greater than 9. So you need to look on your chart and find things that are greater than 9. Well, 1, 2, 3, 4, 5, 6. There's 6 different outcomes that I would want. Since we're doing probability, you want to do what you want divided by what's possible. We look, there's 36 boxes there if you counted them all. So the answer is 6 divided by 36. If you put that into your calculator, you'll get a decimal. That decimal is 0.16 repeated. You then need to go look and change all of these answers to decimals and just match up the decimal with your decimal. 6 over 36 is the same thing as 1 over 6. So the answer was B. If you change them both to decimals, you get the same decimal. 0.16 repeated. Number 14. 2 dice are rolled at the same time. Let A represent rolling a sum greater than 7, and let B represent a sum that is a multiple of 3. Determine, N means number, right? So the number of rolls where you get A and B. So how many times could you roll this dice and get a sum greater than 7 and a multiple of 3? Multiple of 3 means you count by 3. So 3, 6, 9, 12, so on. Well, let's look back at our chart. Here's all the possible outcomes from rolling these dice, right? We want greater than 7. These are the numbers greater than 7, underlined in purple. And we want to be a multiple of 3. I'll underline those in blue. Anything that has 2 lines means it's in A and B. So it's greater than 7 and it's a multiple of 3. These 1, 2, 3, 4, 5 are the only things that are greater than 7 and a multiple of 3. There's 5 things that are greater than 7 and a multiple of 3. Number 15. Candace determines that her mom will cook ham as the main dish for supper as a probability of 0.5. She also figured out that the side dish will be a Caesar salad has a probability of 0.25. Given these events are independent, determine probability of ham and Caesar salad. They told you they're independent, which means you actually could look up a formula if you wanted. This is our independent formula. This is the probability of A equals probability of A. Probability of A and B is probability of A times probability of B. But I really just remember that and means multiply. So I'm going to multiply these two things together. 0.5 times 0.25 That will give me a decimal. I believe the decimal is 0.125. And then I'm going to change these to decimals until I find one that matches. 1 divided by 8 matches. So the probability that you get ham and Caesar salad is 0.125. Number 16. Select events that are mutually exclusive. Mutually exclusive means can't happen at the same time. Right? They can't both happen. So event 1, walking to school on a Wednesday. Event 2, raining in the afternoon on a Wednesday. Well, both those things could happen. I could walk to school and it could rain. So it's not those. B, rolling a sum of 4 when rolling a pair of dice. Rolling all even numbers when rolling a pair of dice. Well, if I rolled 2 and a 2, those are both even numbers, and they add to be 4. That means it is possible that those things both happen. Event 1, being the captain of your soccer team. Event 2, scoring the game-winning goal for your soccer team. Well, it is possible you could be the captain and you could score the game-winning goal, so it's not that. And this one, rolling a sum of 8 when rolling a pair of dice, rolling a sum of 11 when rolling a pair of dice. I could not do both those things at the same time on the same roll. Those are mutually exclusive events. 17. Select the mutually exclusive events. Rolling a sum of 9, rolling a multiple of 3. Multiples of 3 are things that you count by 3. The sum of 9 is a multiple of 3. So that is not mutually exclusive. I could roll a 9 and it would work. Passing math or playing hockey, it is possible to do both those things. You could pass math and you could play hockey. Walk to school today or ride the bus to school today. You either did one or the other or something else, right? But you couldn't have walked to school and taken the bus to school. That wouldn't make any sense. So those things are mutually exclusive. You do one or the other or something else. And just to make sure we're right, D is flipping a coin, getting heads, or rolling a dice and getting a 2. It's definitely possible to do both those things at the same time. I could flip a coin and get heads, then I could roll a dice and get a 2. Use the following information to answer the next 2 questions. Miss Round is taking both chemistry and biology in the same semester. She determines the events are independent, that there's a 0.8 probability of passing chemistry and a 0.5 probability of passing biology. Determine this. That means you pass chemistry and biology. We know and means multiply. So we do chemistry times biology. Throw that in your calculator, and you should get 0.4. Right? Anytime we are doing probabilities where it's something and something, then we're multiplying those probabilities together. They also give you a hint. They said they're independent. The independent formula would tell us to multiply. Determine the probability of C or B. Okay. Or means add. But there is a trick to this. Because these events are not mutually exclusive, that means we need to do the probability of passing chemistry plus, so add, probability of passing biology, then subtract the probability that you pass both at the same time. Because you don't want to double count them, right? So this would be 0.8 plus 0.5 minus 0.4, which you calculated from the question above, for a total of 0.9. That's the probability you pass chemistry or biology. 20. Select the events that are independent. Independent events are events that do not affect each other. Meaning if one of them happened, it wouldn't change the probability of the other one happening. Question A. A bag has 3 red candies and 4 green candies. You grab a red candy and then another red candy. So, did the probability of grabbing a second red candy change when you grabbed a red candy first? And the answer is yes, it would change, right? So the probability of pulling a second red candy would be lower because there's less red candies in the bag after you took out the first red candy. Those are not independent. They do affect each other. You roll 4 on a dice, then you roll 5 with the same dice. When rolling a dice, does what you rolled on the same dice before make a difference? The answer would be no, right? Those things do not affect each other. Once you roll a dice and you pick it up, it's a new roll. They do not affect each other. C, you study for a math test and you pass the math test. Studying will affect the probability of passing the math test, so those are not independent. And D, in a box of 100 toys, 3 are broken. You randomly grab 2 non-broken toys from the box. The probability of pulling 2 out would be pretty hard. After you pull the first one out, the probability of pulling the second one out again would be lower because there's less broken toys to pull out because you already pulled one out on the first pull. Those are confusing concepts, the independent, dependent events. So I would definitely go back and maybe just study a little bit of those questions if that's tough for you. Okay, numeric response. Use the information below to determine the answer. The odds in favor of 4 events are shown below. Event 1, Event 2, Event 3, Event 4. List the events from least likely to most likely. Okay, the best way to do this is to make them all decimals because it's the best way to compare probabilities. This is odds in favor. That means this is what you want, this is what you don't want. If you converted all of these to probabilities, the first number would always be the top number because that's what you want. And then if you added the numbers together, 7 plus 12 is 19. The probability is 7 out of 19. And if you kept doing that for all of these, this would become 15 over 19. This would become 14 out of 17. And this last one would be 21 out of 26. You could then change all of these to decimals, and the largest decimal is the most likely to happen, right? So go ahead, change all of these things to decimals. 7 divided by 19 is 0.37. 15 divided by 19 is 0.79. 14 divided by 17 is 0.82. And 21 divided by 26 is 0.81. So to list these from least to most likely, it would go 1, 2, 4, 3. From least likely to most likely. All right. List the first numeric response box. Place the number for the answer to this. Okay, that means the number in the universal set. So that would be how many numbers are there here. If you look, there's 9 numbers total. Right? There's 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers that are used. That means overall in the universal set, there would be 9 numbers. Question number 2. 2 is place the answer for n of x and y. So that means numbers that are in x and in y. That means in both. If you look, there's no number that are in both x and y. Number 3, place the number for x not. Sorry, the number of things in x and z, but then this means not in x and z. So which numbers are not in x and in z? Numbers that are in x and z would be 1 and 5. Those are the numbers that are in x and z. So numbers that are not in X and Z would be 2, 3, 4, 6, 7, 8, and 9. Meaning that there's 7 numbers that are not in X and Z. And the last one, number of things that are in X or not Z. So you're looking for things that are in X or not in Z. Things that are in X. 1, 3, 5, 7, and 9 are all in X. Or just not in Z. So for instance, the number 2 is not in Z, and we haven't included it yet. 4 is in Z. 6 is not in Z. 8 is in Z. So the things I've underlined in blue are either in X or not in Z. That's 1, 2, 3, 4, 5, 6, 7 outcomes. The answer was 9, 0, 7, 7. Awesome. Here's a Venn diagram. 4 statements are made. Label them 1 or 2. So if it's a true statement, you put a 1. If it's a false statement, you put a 2. Events A and B are independent. Independent means that the chances that one of them happens would affect the likelihood of the other one happening. To test this, oh my goodness. To test this, take one of your events. So it's like take A. Probability of A would be that there's 17 things in A, right? 10 plus 7, there's 17. Divided by the total number of things in this Venn diagram. The total number of things is 52 things. So 10 plus 7 plus 35. So we put that in our calculator, 17 over 32. And I can tell you that the probability of A is 17 over 52. The probability of A is 0.33. Okay, probability of A given that B's happened. Okay, that's the independent test. So you want to check the probability of A if you know that you're in circle B. So if you know you were in this circle. Well, there's now only 7 things that I want because there's only 7 things that are in A and B. Divided by, there's now only 42 possible things because I know that I'm in circle B. And there's 42 things in circle B. If you go 7 divided by 42 in your calculator, your probability is 0.16 repeated. These probabilities are different. This means that if I know B happened, the probability of A happening decreased. These are not independent. That would be a false statement. These events do affect each other. Probability of A and B are mutually exclusive. They are definitely not mutually exclusive. Mutually exclusive means they can't happen at the same time. If you look at your Venn diagram, the Venn diagram specifically is showing you they can happen at the same time. 7 times they happen at the same time. Statement 3. Probability of A or B cannot be determined. You could definitely calculate the probability of A or B. You can always calculate the probability of A or B in a Venn diagram as long as you have all the numbers in the Venn diagram. So that is false as well. You could calculate that probability. You just add the probabilities together. And statement 4, the odds against event B are 3 to 7. Okay, we want to go against B. Okay, so that means you don't want B first. Well, don't want B. There's 10 things that I don't want. I do want B go second. There's 42 things that are in B. You could reduce this by dividing both those by 2. and you get 5 out of 21, which is not 3 out of 7. That means it's false. Every one of those statements is false. It's 2, 2, 2, 2. Awesome. Triple Venn diagram, then we're done. Place the following information in the Venn diagram. A group of 100 students were surveyed about different sports. All the information's there. Okay, let's start plugging it in. 2 people play all 3 sports. Okay, that means this is a 2. 12 people play soccer and hockey. Okay, this is soccer and hockey right there, B. However, I've already counted 2 people that play soccer or hockey. That means only 10 people go in spot B because this is soccer and hockey. In total, there should be 12 people there, which there is. Right? 10 of them are only soccer and hockey. 2 of them are soccer, hockey, and basketball for a total of 12 people that do soccer and hockey. It's called subtracting your overlap, right? All right, next one. 10 people play soccer and basketball. 53 play soccer. We can't do that yet. The reason we can't do that yet is because we don't know how many people are here in the soccer bubble. So I move on to the next one. 10 play soccer and basketball. That means 8 people go here for a total of 10 in soccer and basketball right there. Perfect. 18 play hockey only. That means 18 goes right there. They said only, which means there's 18 that go on that outside. 23 people play hockey and basketball. I've already counted 2 of them. That means there's 21 that go in that spot for hockey and basketball. 6 people do not play any of the 3 sports. There's a 6 on the outside. Only things we're missing here are the people that play soccer and people who play basketball. Well, it told me that 53 people play soccer. So if I take 53 and I subtract the people that are already in the soccer bubble, that should give me 33 people who only play soccer. Perfect. How do you find the people that play basketball? Well, they told you that there's 100 students in the survey. So that means all those numbers should add up to be 100 in our Venn diagram. If you take your Venn diagram and you add them up, that's 18 plus 21 plus 2 plus 10 plus 8 plus 33 plus 6 people who don't play anything. That equals 98. Meaning I'm missing 2 people to get to 100. Those are the 2 people that play basketball. Now my Venn diagram is complete. I can go ahead and look at the statements. It says that there's 4 true statements. E minus A equals 15 is false. So that didn't work. Value of C is equal to value of G. That is true. The circle C and circle G are both 2. More people play hockey than soccer. If you add everybody up in the hockey and you add everybody up in the soccer, you should find that more people actually play soccer than hockey. Let me just make sure that's right. Yeah, more people would actually play soccer than hockey, so that's false. The value of F is 8. That's actually true. One of the region has 0 elements. That's false. And the odds against a student playing basketball are 67 to 33. If you look, that actually is true. It said there's 4 true statements, so maybe I messed one up. More people play hockey than soccer. 41. Oh, that's actually not true. It's not false. More people play hockey than soccer. No, that is false. What am I missing? Oh, E minus A is 15. Sorry. Very first one. That's true. That's just the sickness getting to me here. E is 33. A is 18. E minus A is 15. That's true. So the true statements were 1, 2, 4, and 6. And last one, the number of people who play hockey or soccer minus the number of people who don't play basketball. A number of people who play hockey or soccer. So you go up here, you add everyone in hockey and in soccer. Add all those numbers I just put a circle around. If you add all those numbers up, it should give you 92 minus the number of kids who don't play basketball. Okay, number of kids who don't play basketball. These kids don't play basketball. The ones I've circled in blue. So you'd go 33 plus 10 is 43, plus 18 is 53, 61, plus 6, there's 67 kids who don't play basketball. If you do 92 minus 67, you should get, I think, 25. But given how my mental math is going, I should probably add it up. It is 25. The answer is 25. Awesome. There's all the answers to the quiz. Hopefully that helps out. If you need help with anything, please send me an email or go see Miss Shaw or Miss Tuckalug or Mr. Blinkhorn or Mr. Bell or someone during Flex. I'm not going to be there all week. I'm stuck quarantining. So please, please, please reach out for help. All right. Thank you very much. See you guys soon.